Hello and welcome everyone. Thank you for taking the time to join us today. My name is Abdel Jabbar. I'm a support engineer at Grandstream Networks, and I will be hosting today's training session about the initial configuration of GWN access points. So we are going to talk about the configuration and deployment of GWN access points and share some basic recommendations on how to plan, optimize your wireless network. So this is going to be a mini training session about the initial setup of GWN access points through GWN.cloud. This is not certification training, but at the end of this webinar, I will guide you on how to register in an online class and take the certification exam if you are interested. It's a free online course that you can watch at your convenience. Without further ado, let's get started. When designing a wireless network, there are many factors that must be taken into consideration to determine the best way to optimize the wireless network. And the design phase of any project must include site surveying, which helps gather information about the physical environments in which the access points will operate. One technique used to process the site information to estimate the wireless signal propagation in the surveyed area is called predictive site survey. And predictive site survey is a virtual survey that is conducted off-site, and it uses the facility floor or the blueprint and some relevant information to determine some useful results, such as the expected signal propagation, the number of access points needed, and their optimal placement. This type of site survey is usually completed with a software tool that basically simulates the signal coverage based on the information you feed into the tool. Unfortunately, not all installers have these tools, maybe because they are too expensive or not enough budget to run a site survey. So these are some basic guidelines that you can use when conducting a site survey without any software tool. So we're going to use this floor plan as an example throughout this webinar. Studying the floor plan or a visit to the location can be used to gain an understanding of the site so that you can accurately decide on the number of APs needed and their optimal placement. Also, checking the facility boundaries can help determine if outdoor APs will be used and if there are any interference from surrounding or neighboring access points. Taking notice of the building materials used in the facility will help you predict the signal behavior and visualize potential limitations for AP mounting. The different obstacles located between the access point and the wireless client may reduce the signal strength. For instance, deploying access points in a building made of concrete walls is not the same as deploying them in a building with drywall, because concrete walls tend to absorb the wireless signal at a higher level. Also, considering client's capacity and estimating the number of wireless clients that will be accessing the wireless network can help you determine the area where you need to deploy more access points. So in our plan, we can see that the area with the cubicles will have multiple users with eventually more wireless devices. So that tells us that this area is a high density area that will require 2 or more high density access points. Also, identifying the type of applications and the wireless devices is crucial to estimate the amount of bandwidth required and whether QoS for such applications is needed. Also, you learn about the stations and the wireless standards they support. For example, you can't configure the APs to use 802.11ac only, while you have clients with legacy wireless cards that support only 2.4 gigahertz, because these clients will never be able to connect on a 5 gigahertz band. So after you determine the variables that we have explained so far, then you can design the AP layout. Of course, you want to cover the entire surveyed area with a strong signal. The floor plan and the collected information can form the basis for determining the optimal coverage and bandwidth needed based on the number and type of wireless clients. For example, in the cubicle area, we can deploy 3 high-density access points to ensure both speed and coverage in that area. So selecting the right access point model for your deployment is also important. For instance, in a high-density area, you want to go with a high-density access point that has more antennas or special streams and, of course, higher throughput. Wireless network segmentation is another thing that you need to plan ahead. For instance, how many SSIDs will be needed, and is there going to be a need for VLANs? One thing to keep in mind is that the more SSIDs you create, the more overhead you add to your wireless network, because the access point will need to broadcast the information regarding each SSID in the wireless network. So when it comes to radio frequency signal attenuation, it occurs naturally with distance. And when you have obstacles between the access point and a client, the attenuation gets more significant, because when a signal passes through an object, part of that signal is absorbed. The figure shown on the right hand summarizes relative attenuation values from different building materials, and as you can see, concrete walls yield the greatest signal attenuation as compared to the other material types. So while considering the different building materials and their thickness can be helpful for estimation purposes, post-deployment validation and testing in the physical facility is the best way to determine whether wireless communication will be successful across the rooms and areas. With that said, after you deploy the access points, walkthrough might be required to ensure there are no dead Wi-Fi spots. Because of the attenuation problem imposed by the construction materials, in some cases, the wireless administrator might decide to increase the radio power of the access point to allow the signal to penetrate those construction materials to reach the wireless client. The challenge with that one is that the signal from the access point to the client is able to reach the client because the access point has powerful antennas. However, the signal from the client to the access point might be too weak to reach the access point, which can lead to an increased rate of retransmission from the client, which will eventually slow down the network. So basically, when you increase the radio power of the access point, you always want to go to the access point web interface and check the RSSI of the wireless client detected by the access point. And during the live demonstration, I'm going to show you where you can find that information. We talked earlier about AP selection. So depending on the area where you're going to deploy the access point, that's going to help you determine which access point model to go with. So Grandstream offers a wide range of access points that fit different types of deployment. So we have low density access point all the way to high density access point. And the main difference between these access points is the number of antennas that is built into the access points, because it allows it to talk to multiple wireless clients. Also the wireless capacity of the wireless clients. So while the low density models can support up to 100 wireless clients, the high density access points can support up to 512 wireless clients. And the number of antennas is usually related to to the aggregate throughput provided by the access points. Grandstream also offers Wi-Fi 6 capable access points in case you want to deploy them in your wireless environment. So when it comes to the management of the access points, there are two ways how you can manage the access points. All GWN access points come with a built-in controller that allows you to manage up to 50 access points in the same local area. And the way you enable the built-in controller on the access point is basically the first access point that you connect to. That's going to become the master or the controller. And from the web interface of the controller, you can discover and pair other access points and add them to the web interface of the controller so you can manage all of them from one single interface. So again, built-in controller works only with access points in the same local area network. In case you have more than 50 access points, but you still want to manage them locally, Grandstream offers a free software called the GWN Manager that you can install on a Linux machine. And this one allows you to manage up to 3,000 access points in the same local area network. The second type of management that Grandstream offers is the cloud management through GWN.cloud. Basically, the cloud management platform allows you to manage a limited number of access points spread across multiple locations, and you can manage them from one single interface. So for today's live demonstration, we're going to use GWN.cloud to show you how you can add access points and how you can manage them. We will also go through the configuration parameters available through GWN.cloud. So I'm going to switch to the web interface of GWN.cloud. This is my account. I'm already logged in. If you want to create an account, you simply go to GWN.cloud and you can sign up for free, and you can add as many devices as you wish to your GWN.cloud account. So GWN.cloud is designed in a way that allows you to manage multiple networks from one single management interface. And the concept of network used in GWN.cloud can mean an organization, can mean a site, a branch. So it depends how you want to manage and segregate your wireless networks. For example, an installer can create a network for each client and then simply go to the client name and click on it so that you can add access points to that specific client. GWN access points also allows you to assign user to manage specific network in your GWN.cloud. I can show you that at the end of the presentation, how you can add users and assign them only specific networks to manage. In case you want to add more networks, you simply go to create network. So I already have few networks created here. So let's go ahead and choose the GS network. So once you switch to the network that you want to manage, you go to access points, because that's the first step, is that we need to add access points to the network. And as you can see, I already have 3 access points added to this network. If you need to add more access points, you simply click on add. The GWN.cloud is going to prompt you to enter a name. This is just to label the access point. It could be anything, but there are 2 pieces of information that are required to add an access point to your GWN.cloud. The first one is the MAC address and the initial password, and both of them are included and printed in the sticker on the back of the access points. In case you want to import a large number, let's say you're talking about dozens or maybe hundreds of access points to your GWN.cloud, you can use the import option. Just make sure you use the template that is provided to you here. Just click on it, download it, and then fill it out with the information. So there are 3 columns, one for the name, the MAC address, and the password. Once you do that, then you just come here, click to upload the CSV file, and all the access points will be uploaded automatically under the access point configuration page. Another way to add access points to your GWN.cloud is using the GWN app on your iOS and Android devices. The app is built with a scanner that makes it very convenient to add devices to your GWN.cloud. You simply use the scanner and you scan the barcode in the back of each access point. So after you add the access points under the access point configuration page, you can also check the status, by the way, just by going to status. The green dot means they are online. Sometimes the dots can be gray, especially when the access point is offline. So after you add them to your GWN.cloud, the next step will be to create an SSID. By default, when you add GWN access points to your GWN.cloud, the SSID GWN-cloud will be assigned to these access points automatically, and you will see that broadcast by the access points. One thing that I would recommend is after you create your own SSID, just make sure you go to edit and disable this SSID. Alright, so let's go ahead and create an SSID and then go over the available parameters. So the first thing, we're going to assign it a name. We can call it Office. And of course, we must check enabled if we want to use this SSID. Next, we have the client IP assignment. We have two options, bridge and NAT. So the bridge, basically the access point would work as a bridge, which is usually how you have it set up. The other option is NAT. So when you set this option to NAT, you allow the access point to act as lightweight router with the HCP service. Let me switch to this slide. So the access point will create a segregated network for connected devices. In this mode, the wireless devices will be able to access services in the wired network. However, it would prevent any other users on the wired network and any other SSID that is created on the access point from communicating directly with the wireless devices in that SSID with NAT mode. So you basically create a segregated network where access to that network is not allowed, but devices inside the segregated network will be allowed to communicate with devices in other wireless networks and in the wired network. So let's go back to the GWN configuration page to continue the configuration of the parameters. And as you know, all Grandstream devices are dual band Wi-Fi. They work on both 2.4 and 5 gigahertz. In case you want to use a specific band such as 5 gigahertz, you can change that one to 5 gigahertz. However, just keep in mind, once you set that one to 5 gigahertz, if you have any legacy devices that don't support 5 gigahertz, they won't be able to connect to this SSID. So I'm just going to leave that one as dual band and change that one back to bridge. In case you are using VLAN, like you want to use VLAN on the wireless network, you just check this option and enter the VLAN tag. Another thing to keep in mind is when you try to assign VLAN to your wireless network, just remember to set the connection between the switch port and the access point to trunk mode, especially when you have multiple VLANs created on the same access point. Alright, next, so access security, we have the encryption protocols. WPA, we have WPA3, we have OSIN in case you want to use the hotspot 2.0. Just keep in mind, if you change any protocols, if you set that one, for example, to WPA3, just make sure that the wireless devices also supports WPA3. So I'm just going to leave that one to WPA2. You have two options. There's the pre-shared key, which is the simple way of connecting to Wi-Fi by simply using a password for the Wi-Fi, or you can use the 802.1x in case you have a Radius server that you want to use for authentication and accounting purposes. Usually this is implemented in an enterprise environment. So let's go ahead and change that one to pre-shared key. and we can assign it a password. This is in case you want to use captive portal with that SSID. You can do that just by checking this option. But first of all, you have to make sure there is a captive portal created. If you want to learn how to create a captive portal, you can always go to the Grandstream YouTube channel. We have a tutorial about how to set that up on the GWN access point. So once you create the captive portal, and if you want to use it with like Facebook or Twitter authentication, just create one, and once you have it created, you can come here and select it. So I'm just gonna uncheck this box. The other option is MAC filtering for access control. You have two options. There's the whitelist, where you can define the whitelist. So basically, when you configure a whitelist based on the MAC address, those are going to be the only MAC addresses to be able to access this Wi-Fi through this SSID. If you choose the blacklist, then the ones in the blacklist will not be allowed to connect to that SSID, and all other MAC addresses can connect to the same SSID. The next option is client isolation, and the wireless client isolation is a security feature that prevents wireless clients from communicating with one another. And this feature is usually enabled for guest SSIDs to limit security threats from devices connected to the wireless network through the guest SSID. And when you enable this feature, you enable it per SSID. So in case you want to use this SSID for guest network, always make sure you check that one to add some layer of security. So when you check this option, you have three options. There's the radio, internet, and gateway MAC. So the obvious one is the internet. So once you set that one to the internet, the devices connected through that SSID can only access the internet. They can't talk to any device in the same private network. If you set it to radio, the wireless devices cannot talk to one another. However, they can access the access point configuration page. They can also ping the access point and the router. If you choose the gateway MAC, they can only access the internet and the router. So all these options allow them to access the internet, and at the same time prevents them from communicating with devices in the same private network. So I'm just going to close that, and let's uncheck this one for now. The other option is 802.11w. This is a security feature that ensures the integrity of management frames. Some legacy devices that do not support 802.11w may not be able to connect to this SSID, and this is due to the fact that some legacy devices don't know how to handle the advertised information contained within the beacon. Also, if you change it to required, you must ensure that all devices support 802.11w. Otherwise, the devices will not be able to connect to that SSID. So I'm just going to disable it for now. There are some other options here that we can go over too. So the first one is hidden SSID. In case you want to hide the SSID from being broadcast, you can check this option. The other one is the wireless client limit, in case you want to limit the number of wireless devices. So if I set it to 20, so only 20 devices can connect to the access point per radio. The inactivity timeout is 300 seconds, which is 5 minutes. So when there is a device that is not sending any traffic to the access point and it's being idle for like more than 5 minutes, the access point will just remove that client from its table. The other option is client bridge. This is in case you want to create a wireless bridge between two access points so that you can extend the wired network over the wireless medium. In case you want to learn more about this topic, we have a video tutorial on the Grandstream YouTube channel in case you want to learn how to configure it. So for now, we'll just uncheck this option. Client time policy. This option basically allows the access point to define the duration of Wi-Fi access. So if I set that one, for example, to guests, and I enable the time policy, if I set that one, let's say to 4 hours, that means anyone who connects to that SSID can only have access to Wi-Fi for 4 hours. And the access point will reset the timer every day at 12 a.m. So they can only have 4 hours of Wi-Fi access every day. But for now, we're not going to use that. Multicast broadcast suppression. So basically, when you enable this option, the access point will block all types of multicast and broadcast except for DHCP multicast and ARP requests. So now I will just disable that one. It's important to keep these two options disabled, especially when you are using multicast paging with the endpoint devices such as IP phones. Schedule icon set a time when Wi-Fi access is allowed. If I choose this time, that means Wi-Fi access through that SSID is only allowed during this period of time that is highlighted. So I'm not going to use any schedule for now. If you want to use multiple access points and you want to provide roaming feature for endpoint devices, GWN access points support the voice enterprise, which is built on the 3 standards 802.11r, K, and V. So these standards, basically when they are enabled, they allow the wireless devices to roam faster because each one of these standards has a mechanism to speed up the roaming process of wireless clients. For example, one of them will speed up the authentication process. The other one will provide the wireless clients with information regarding the neighboring access points so that they know which channels they are using, so that when they probe the access point, they can probe them on the channel that they are using instead of probing all the channels. And that reduces the time of the roaming. The other standard also provides the wireless devices with information regarding the load on the access point. So if there is one access point with so many clients and there is another one that is close by and providing a decent signal strength, the access point can provide that information to the wireless client so that it can roam to the next access point that has less load. We made a video regarding these standards. If you want to learn more about them, just by simply going to the Grandstream YouTube channel and search for Grandstream roaming. Alright, so once you create your SSID, you go to device membership and then you select the access points that you want them to broadcast that SSID. Let's say if I only want these two, I can remove that one to the available devices so that only these two access points can broadcast the SSID that we just created, which is Office. So let's go ahead, save and apply. So we're missing some. Oh yeah, so let me remove that. So now that we created the SSID, most of the time when you deploy the access points, you need to go back to the access point settings and make some changes. But before we go to each access point and make those changes, I just want to mention something regarding the radio settings. So the radio settings on this page work as a global template for all the access points in this network. So these are the settings. Every time you add an access point to this network, they will inherit those settings under the radio configuration page. So let's look at those settings and then we can go back to the access points. You can always go back to the access points in case you want to make specific changes to a specific access point. Like in case you want to override the default settings. But first of all, let's look at these settings at the radio configuration page. So the first option is band steering. And band steering is a feature used in dual band APs to prioritize the use of a band over another. For example, in a high density Wi-Fi environment, you might want to prioritize the use of 5 GHz band, which has a higher capacity and it is less susceptible to congestion and interference. While at the same time, you want to make sure that 2.4 GHz band is also available for devices that don't support 5 GHz. Remember earlier, under the SSID, it gave us the option to select whether 2.4 or 5 GHz. So the option available under SSID, basically you restrict the use of 5 GHz or 2.4 GHz in case you select one or the other. But with band steering, you only prioritize. You make both of them available, but you only prioritize one over the other. And the way it works, when a dual band device tries to connect to the access point, the access point will push the device to connect on 5 GHz by ignoring any attempt by the device to connect to the 2.4 GHz. The other option is client steering. So when you enable this option, you get two other options. There's the SSID threshold. If you set that one to -75, that means the access point can only accept connection from devices that connect with an RSSI value of -75 dBm. You can increase that one in case you have issues with coverage. You can increase it to -80, so you can allow devices with relatively weak RSSI to still connect to that access point. The other option is the client access threshold. So if you set it to 30, that means the access point can only accept 30 clients on that SSID. So I'm just gonna disable this one. The other option is airtime fairness. Let me bring this slide to further explain how it works. So this is how airtime fairness works. When the airtime fairness is disabled, this is what happens when you have a slow rate device and a high speed device. The slow rate device, as you notice, will take more time to transmit a small chunk of data, while the high-speed device will send more data in a shorter time. But the problem here is that the high-speed device will have to wait longer for the slow rate device to transmit its data. And this causes the high-speed devices to become a little bit slower because they have to wait longer. When you enable airtime fairness on the access point, what happens is that the access points will allocate the same amount of time to all devices, whether they are high-speed devices or low-speed devices. And as you can see here, I mean, these are like 4 seconds here. These are only for illustration purposes. In reality, it is a matter of milliseconds that is allocated to each wireless device. The downside to enabling the airtime fairness is that the slow rate devices will get even slower because now they have less time to transmit the data, but it makes the high-speed devices faster because now they don't have to wait longer for the slow speed devices to transmit all their data. All right, so you can enable this option in case you have some fast devices that are suffering from other slow devices in your network. Otherwise, you can just leave it unchecked. Some settings I would not recommend changing them, including the beacon interval. 100 is the standard. The other option is the Wi-Fi 5 compatible mode. This option, you only enable it when you have Wi-Fi 6 access points deployed. And in case you want to disable Wi-Fi 6 features, you can check that option. We can just leave it unchecked for now. The other options that you have here is the channel width. As you know, 2.4 gigahertz only allows us with 3 non-overlapping channels, and each channel has a width of 20 megahertz by default. So that's why we get 11 channels, especially here in the US for the 2.4 gigahertz. In case you want to increase that one to 40 megahertz, you basically increase the rate, or you increase the data rate of the channel But this one has a downside to it, because once you increase the width of the channel, now you have only one channel that you can use. And if you have multiple access points deployed in proximity, you will not have other channels to use. So that could create what we call the co-channel interference, because you only have one channel to use on all the other access points. So I would always use 20 megahertz when it comes to 2.4 gigahertz. The only situation where I would change it to 40 megahertz is when I only have one access point and isolated. The Grandstream access points, they are built with what we call DCA, or dynamic channel assignment. It uses an internal algorithm to detect the channels that are being used by neighboring access point, and based on that it decides which channel is less congested and assign that one to the access point. In case you want to do that manually, you can always do it from the access point. So you have to go to the configuration of the access point and assign them specific channel. So the radio power under the global templates are all set to high, and most of the time when you have multiple access points installed in proximity, you will need to come here and change the power from, let's say, high to medium or low. Let me show you this example so you can understand why we need to change the radio power of the access point after we deploy them. So to use the same floor plan that we talked about earlier, so we deployed the access points, and as you can see, all of them are using the high radio power. Here we are using the 2.4 gigahertz channel just for illustration. So we have 3 non-overlapping channels, and each channel is represented by a color. So what happens here is that access point 5, 2, and 7 are all transmitting over the same channel. We can say, for example, channel 6 or channel 1. The problem when you have the access point transmitting with a higher power, the signal from both access points that are competing over the same channel, they can start hear each other, and that creates what we call the co-channel interference. The co-channel interference basically when two access points are transmitting over the same channel and they can hear each other. Because the problem with that is if access point 5 is transmitting and access point 2 listens to the signal from 5, it will halt all the transmission. It's like it's going to wait for access point 5 to finish transmitting its data. So both of them are going to be competing over the same channel, and that is not good for your wireless deployment. The same thing applies to access point 7, because when it hears the signal from access point 2, it needs to stop and wait for its turn to transmit. So when you have the access points in a small area and all are used in high power, you get the co-channel interference. The same thing applies to 5 gigahertz. We only used 2.4 gigahertz because it's easy to illustrate. The other issue that could happen with access points transmitting with higher power is, look at this area. It's a small area because we have a lot of users, so we decided to deploy 3 access points so that we can provide the users with higher throughput and reduce the congestion in that area. So another problem that could arise is the situation where we have sticky clients, and a sticky client is a client that is connected to an access point that is further instead of connecting to the access point that is closer. And that happens because the signal from the access point 2 is too high that the wireless client thinks that this access point is actually close by. So that's why it remains connected to this one. So what we need to do in such a situation is we need to adjust the transmit power based on the area. So the area where the cubicles are, we need to reduce the power of these access points because they are deployed very close to each other. Also in the video conferencing room and the training room, since we only need to cover this small area, we can adjust the radio power. So this is how it looks now after you adjust the power, let's say to low radio power instead of high. First of all, you get rid of that co-channel interference between access point 2 and access point 5, as well as access point 7. And also the sticky client that was here now is not able to connect to this access point because it's not seeing its signal, or maybe the signal is just too weak for the client to connect to that one. So after you adjust the radio power of the access points, you always need to check the RSSI. And the RSSI can be verified from both the wireless client by simply going to the settings of the device and also go to the access point configuration page and the client, which I'm going to show you in a moment, where you can see the RSSI. It's important to verify it from both sides because, as I mentioned earlier during the presentation, if the signal from the access point is too powerful, the device will detect the signal with high RSSI, like with a good RSSI value. But when you go to the access point, you find that the signal from the wireless client to the access point is really weak. So let's go back to the GWN.cloud and continue the configuration of the parameters. So you can change that one, for example, to low if this is deployed in the cubicle areas. Sometimes you can set the 2.4 gigahertz to low, then you can go to 5 gigahertz and change that one to medium. Because as we know, the 2.4 gigahertz has a longer range compared to 5 gigahertz. And also 5 gigahertz gives us more channels to reuse. So we have more channels compared to 3 channels in 3 non-overlapping channels in 2.4 gigahertz. The same thing applies here. You can increase the channel width from 20 to 40 or 80. I would not suggest using 80, especially when you have multiple access points in a small area. If you only have few of them, you can use 40 megahertz so you can increase the data rate. But if you have so many access points deployed very close by, you can choose the 20 megahertz so you don't run out of non-overlapping channels. All right, the other option is DFS. DFS, as you know, or dynamic frequency selection. And the dynamic frequency selection includes some channels in the 5 gigahertz that are usually used by radars, like military radars, weather radars, some other services that use those channels. And in case you want to enable DFS, there are 2 things to keep in mind. Make sure that your area doesn't have any military or weather radars that are broadcasting over the same DFS channels. That's number 1. Number 2, some wireless devices, like the chipset in them, is not designed to work on the DFS channels. So that's something to always keep in mind, especially when you enable this option and you notice that some devices are not able to connect. Always go to the wireless device and check if they actually support connection on the DFS channels. Yeah, other parameters available for both 2.4 and 5 gigahertz is the minimum RSSI. So if I set that one to 80, then only devices with an RSSI of minus 80 dBm can connect to this SSID. You can also choose the data rate, because the further from the access point, the lower the data rate. And if you have a wireless device that is way further from the access point, that device will most likely be transmitting over a lower data rate. And when it does, it's going to slow down the whole wireless network. So you can specify the data rate allowed by the wireless devices. If I set that one to 54 megabits per second, only devices that have negotiated data transmission of 54 megabits per second can connect to that SSID. So I'm just going to uncheck these for now. So save and apply. So whatever you configure here will apply automatically to all the access points. In case you want to make specific changes to a specific access point and you want to keep the default settings under the radio configuration page, you just go to access point configuration and you select the access point. And you will find that most of the settings that we saw in the radio settings are available here. So as you can see here, it says use radio settings. That means it uses the global settings under the radio configuration page. So if I want to change that one on that specific access point, I can do that from the configuration of the access point. So now we added the access point, we assigned them the SSID, we made adjustments to the access point parameters. There are some other settings that you can configure. Let's go ahead and look at the client so we can look at the wireless devices that are currently connected to these access points. So for now, I only have one device connected and it shows online. So when you go to the client status, earlier I was talking about the RSSI. And it is always important to check the RSSI from the GWN.cloud because that tells you the signal strength detected from that wireless device. So -58 is a good RSSI. That means this wireless client has a good connection to the access point, and it tells you which access point it is connected to, which is this one here. It tells you also the negotiated rate. So here we have 65 megabits per second for transmission and 26 megabits for reception. So there are a lot of useful information here that you can use for analysis purposes. If you go to access control, we talked about the access list in case you want to use a blacklist or a whitelist to allow or disallow devices from connecting to a specific SSID. There's the time policy. We also talked about that in case you want to specify the duration of Wi-Fi access to specific users per SSID. There's the bandwidth rules. So that one, when you add a rule, you can actually assign the rule per SSID. Let's say you have a guest network and all your connection is only 20 megabits per second. You can assign the whole SSID, let's say 4 megabits per second. So all the guest devices will have to share that 4 megabits per second. You can assign it per single MAC. This is important, especially when you have video conferencing devices in your environment and you want to dedicate them specific amount of bandwidth. You can do that based on the MAC address. You can do it based on single IP or per client. So basically, when you set the per client, each client that connects through that SSID, let's say the office, will have the same specific amount of bandwidth. And this is where you specify the upload and download limit in kilobits per second. Another useful tool that is built into the GWN.cloud is the site survey. So when you click on this option, it tells you all the neighboring access points in your environment. And it tells you which channels they are using, which protocol they support, what is the channel width being used. Most home routers, they use 80 because in most houses you don't have many access points. So when using 80, it makes sense. But in enterprise environment, you want to reduce that one to 40 megahertz instead of 80. It tells you the RSSI. So these, I can tell that these are in my location because the RSSI is really strong. Some of them are like further away, like this one probably belongs to a neighbor or somebody else. So from here, you can analyze the lot of information that you can use for your wireless deployment. There's also the option of a rogue AP in case you want to detect rogue APs in your environment. We made a video about that one in case you want to learn more about it. You just go to the Grandstream YouTube channel and look for rogue AP on the Grandstream channel. Earlier we talked about NAT. The pool, like the NAT pool, is defined under the settings. It's right here. So this is the NAT pool that you're going to be using when you set the NAT mode in the SSID. Yeah, there are some other options like mesh. We made a video on the Grandstream YouTube channel in case you want to learn more about mesh. In case you have access points that are not running the latest firmware version, you can always go to the upgrade option, and then you can select the access point and you can select the upgrade. And here it gives you all the available firmware version. Sometimes, like when you're running a very old firmware version, you want to go through transition firmware before you jump to the latest one. So GWN.cloud provides you with all these firmware files. You can upgrade it now, or you can schedule an upgrade later based on date and time. Usually when you have an access point that is not running the latest firmware version, you're going to see a pop-up here when you log into GWN.cloud the first time. Another thing that I would like to mention is the user management of the GWN.cloud. So for the management of GWN.cloud, there is the super administrator, okay? And you can actually add users. Let's say this is going to be, I can just use this email for now, gs.com. I can create a user and I can assign that user specific network to manage. And we have two options. There's the administration privilege and there is the read-only privilege. So if I choose network administration, I can choose this network and assign this user the management of only that specific network. So when they log in using their email, they will only have access to that network instead of the super admin having access to all these networks. So once I click add, GWN.cloud will send an email to that user so that they can validate the account, and then they can create a password for GWN.cloud that you can use together with this email that we created here. In case you want to assign them read only so that they can only verify the configuration, you can do that as well. So I think we covered pretty much all the settings on the GWN cloud and how to deploy the GWN access point. In case you want to learn more about the Grandstream networking products, you can go to the Grandstream Academy and you can register for one of the online training classes by simply clicking on the self-training. It provides you with two online classes. So there's one for the unified communication, like the UCM product, and the second one is for the networking solution, which is GWN access point. So if I select this one, it's going to ask me to register. You can register for free. So once you do register, then you can watch all the videos that cover these topics. And once you feel ready, then you can take the exam. And if you pass it, you will get a certification emailed to you. So that brings us to the end of this webinar. Thank you again very much for sticking with us. And I hope you find the content of this webinar useful to you. Thank you, and I'll see you in the next webinar.